Hello and welcome back to the Cracking FAANG YouTube channel. Today we're solving Leetcode 1813, Sentence Similarity 3. You are given two strings, sentence 1 and sentence 2, each representing a sentence composed of words. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Each word consists of only uppercase and lowercase English characters. Two sentences, S1 and S2, are considered similar if it is possible to insert an arbitrary sentence, possibly empty, inside one of these strings such that the sentences become equal. Note that the inserted sentence must be separated from existing words by spaces. So for example, S1 equals hello Jane, S2 equals hello my name is Jane, and these can be made equal by inserting my name is between hello and Jane in S1. And then we have S2 frog cool and S2 frogs are cool, and it's not similar because although you can insert SR into S1, it's not separated by a space, right? So given two sentences, S1 and S2, return true if sentence 1 and sentence 2 are similar, otherwise return false. My god, is this a Leetcode question or a reading comprehension question? Jesus Christ, why the fuck do they do this? Anyway, okay, so pretty straightforward. Basically just need to tell whether you can insert a kind of string in the middle, or not just in the middle, but insert a string and make these two sentences similar. Now, it's important to note that there's three places where you can insert a string. You can do it at the start of the string, you can do it in the middle, or at the end. And you're only allowed one insert. So you can't have multiple. So basically, either it's going to be at the start of one, at the middle, or an end. You can only do one insertion. And then we have to watch out for this case here where if one of the words doesn't match exactly, then we can't do it because we can't insert that. So basically frog and frogs, there's nothing we can do here because there's no frogs in this sentence. So the way that we're actually going to do this is quite simple. We're going to use two decks. And what we're going to do is we're basically going to put all of the words into our two decks here. So the first one, it would be like hello, oops, capital hello, and then Jane. And then the second one is going to be hello, my name is Jane. And what we want to do is quite simple. Basically, we just want to start from the beginning of the deck, and we're going to check the words. Are the words at the same index equal, while we actually have something in the deck? If they are, then we can pop these words, get rid of them, and then eventually we're going to hit a mismatch. So Jane and my. Now, it's not guaranteed here that we actually have Jane in the other sentence. So when we get a mismatch, we're going to stop going from left to right, and then we're actually going to go from right to left, and we're going to check words from the end and see if they match. So basically, okay, Jane and Jane match, so we can pop them. Now this deck is actually fully done, so that means that all we need to do is add my name is basically in the middle. So that's really the algorithm we want to do. We're going to create two decks, and we're going to iterate from left to right. We're going to compare the words as they come, so basically at the start of both decks. If they're equal, we're going to pop from the deck. Otherwise, once we hit a mismatch, we're going to stop going from left to right. Then we're going to go from right to left, and we're going to do the same thing, compare them as they go. If there's a match, we can pop from the deck. If not, then basically there is no answer because the words don't match. So either you're going to pop all the words, or you're going to finish one of the decks, in which case you have a solution. Otherwise, there is none. So let's see how we might code this up. It's relatively straightforward. Okay, as promised, let's now code this up. Now remember that we said we're going to use two decks, and we're going to put into these decks basically the characters, the words in each sentence. So we're going to say that deck 1 is going to equal to collections.deck, and we're going to put in s1.split. And then for deck 2, we're going to do the exact same thing, collections.deck, deck, and s2.split. So now that we have that, we can basically compare the words in deck 1 and deck 2, starting from the beginning. So basically going from left to right. So we're going to say while deck 1 and deck 2, so basically while they have some elements in there, and deck 1 of 0, so the first element, actually equals to deck 2 of 0. So basically while the words are the same. If they're the same, then we want to just keep going through the deck from left to right. So we're going to say deck1.pop left, because we're going from left to right, and then we're going to say deck2.pop left. Okay, so either we will basically get through both of the decks, because in this case they have the same words, or we're going to hit a point where they don't match. And in this case, like we said, we're actually going to go from right to left to see if we can find those words going from the right to the left. So we're going to say while deck1 again, deck1 and deck2, and now we're going to go from the back side. So we're going to go from deck1 minus 1 equals to deck2 of minus 1. So we're going to go from right to left. If the ends of the deck are equal, then we can pop. So we're going to say deck1.pop, and we're going to say deck2.pop. So now, once both of these while loops end, we're going to have the case where either we've gone through both the decks, and we can have the case where we were able to find all of the words in either deck1 or deck2, in which case that one of the decks will be empty, or they could both be empty. In the case that neither of them is empty, that means that there's some words that didn't match and we couldn't find them. Therefore, we don't have an answer. So as long as one of the decks, at least one of them is empty, or yeah, it's empty, then we basically have found a solution. So all we need to do is return not deck 1 or not deck 2. So basically, if either one of them is empty, we can simply just return true, and that will be our solution. So let's run this and verify S1. Oh, sentence 1, okay. Sentence 2, oops, okay, cool. There we go, and accepted, perfect. So before we go, as you know, let's do the time and space complexity. So obviously for the time and space complexity, we put everything into a deck, and then we basically just iterate over the deck. In the worst case, the sentences are actually exactly the same, so we need to basically check every single element. So this is just going to go big O of m plus n, where m equals, well, we need to check basically every single element. So where m equals num words in S1 and n equals to num words in S2. And then the space complexity is, oops, let's see, this is the time. And then the space complexity, oops, is also going to be big O of n plus m, because again, we need to store these values in the deck. So basically, as however many words there are in S1 and S2, that's how many we're going to have to store in the deck. So that's how you solve this problem. Relatively straightforward, quite simple. Good, I guess, for a daily question. Anyway, hopefully you learned something today. Hopefully you enjoyed the video. If you did, why not leave a like and a comment? Helps me with the YouTube algorithm. Subscribe to help me grow, and I will see you in the next video. Bye.